Let's begin with some basic definitions. What is physics? Now, if you're familiar with the show Big Bang Theory, you can remember the piece about Sheldon teaching Penny physics, or you can find that on YouTube. The definition we're going to work with is a little less intense. What we're going to look at is something like the interaction of matter and energy. We can also consider the fact of the universe and everything in it and the interaction or behavior of these constituents. Or we could say the universe is, and so on. So as you can see, there's not much that we're leaving out. Well, we'll back up a tick and say, well, then what is a definition for science? How about a logical process of inquiry? Something really simple. Now, I do not expect you to be able to quote these definitions or any other definition like this. We're more concerned with being able to use these, in other words, create operational definitions. A scientific model is a representation of reality that agrees with measurement and observation. Now, in here, frequently our scientific models will in fact be mathematical representations. A measurement is a numerical comparison to a standard value accuracy would be how close a measurement is to an actual value. Precision would be how close measurements, plural, are to each other. Now, frequently you will see the target the bullseye analogy where accuracy is represented by a situation where you talk about the average of the hits being close to the center, as opposed to precise being the measurements or the hits being close to each other. Which is preferable? Ideally, we would have both. Mathematically, this one can be easier to work with at times, but there are still techniques we can work with to deal with this one. Significant figures, and as we work through especially the first couple of sessions, we will practice and discuss the rules for significant figures. But essentially, significant figures indicate the degree of precision in measurement and the resulting precision in calculations. Scientific notation. If you remember this from previously, that is great. When we deal with very large and very small numbers, this becomes essential. So proper scientific notation has exactly one non-zero digit to the left of the decimal. So you could have something like 3.27 times 10 to the ninth. And essentially what this does then is it shows you the significant figures and then the order of magnitude. Negative 2.0005 times 10 to the negative 6th. In this case, this is a very small number. A negative would imply it's a small number. A positive would imply a large number. And of course, we could mix 3.11 times 10 to the 15th or 2.10157 10 to the negative 5th times 10 to the negative 5th, excuse me. Oftentimes, you will see it in your calculator as 3.27 e to the ninth, or negative 2.0005 e to the negative sixth. Please use the proper input value in a scientific calculator. Do not type this in a calculator. The reason is you have all sorts of mathematical problems with this. The calculators are designed to understand this. The E stands for exponential notation, and scientific notation is a subtype of exponential. Make sure you are entering these things properly. If you have a question, ask me. I may ask you to send me some screenshots or some photographs of your particular calculator so we can make sure you're entering these correctly. I will tell you that come test time, one of the places I have no sympathy is when you have not learned to properly enter things in the calculator and your numbers are completely wonky. Percent error. I'm not typically a fan of the calculation for percent error because it assumes that we know the actual value. Okay, to whatever degree of precision that we need. But the calculation for percent error is simply the measured value minus the actual. Now, in some cases, you'll see it listed in the reverse, but since we have absolute value, it doesn't make any difference, over the actual times 100. So essentially what we're doing is we're simply looking as a percent of the actual value, how far off are we? And we have an absolute value in this case. Percent deviation is simply going to say the same thing, except instead of an actual value, we're going to use the average or the mean. This is particularly useful when we're talking about a range of values, where then we're going to be talking about percent deviation. This is also good when you're looking at a comparison of one measurement to many others.